Welcome to Chapter 8. Chapter 8 is all about global climates and climate change. In the first part of this lecture, I'll talk about global climates, and then when you come back for the second half of the lecture, I'll talk about climate change. We have an incredible variety of climates on our planet. Here you can see two pictures. One is a subtropical desert in Argentina, and then a tropical wet climate in southern Thailand. We just have an incredible amount of climatic variation, making some very, very cool ecosystems. So again, I just want to reiterate again the difference between weather and climate, and we've talked about this before. Weather is the present atmospheric conditions. It changes constantly. Climate is the average atmospheric conditions, which include seasonal patterns, and they change gradually. Climates do change, but very, very gradually. The weather changes every day, right? You can have a rainy day and a dry day, so again, we talked about the weather being what's happening right now. The climate can be like what you're going to expect to happen over a period of time based upon what's happened previously. And they tell us a lot about the place, climate does. And so this could be the weather in Las Vegas, right? It's snowing. But this is more indicative of the climate in Las Vegas, right? It's not usually snowing in Las Vegas, right? It's a pretty warm place. So we have something called the Köppen Climate Classification System. I'm going to go through a bunch of these different climates. They have letter abbreviations that are associated with them. You do not have to know the letter abbreviations with them. What I want you to know is some basic characteristics of these different climate types. There's going to be a bunch of them that are going to come through, but again, you don't have to know the nitpicky details, nor do you have to know the letters. For example, I'm not going to expect you to know that a tropical wet climate classification has the code AF. You don't need to know that. It'll be on the slide, but you don't need to know that. So these are quantitative groups of places with similar climates. They are useful for comparing places around the world. We'll talk about, we live in a Mediterranean climate in San Diego, which is named after the Mediterranean, which is in Southern Europe. And so we have a very similar climate to them. Again, don't need to memorize the codes or the exact names for every type. I want you to kind of notice the general characteristics. And so when you hear, you can see a global climate classification map. And again, just to point out, here is, we are in a Mediterranean climate, Southern Europe, Mediterranean climate, right there. But when you look at a map like this, you could say, you know, the conditions here are going to be pretty similar to the conditions here, are going to be pretty similar to the conditions here. And you should notice a relationship. Here is a map of climate types. Here is a vegetation map. They kind of follow similar spatial schemes. Vegetation is largely dependent upon climate, especially with concerns to temperature and precipitation. Certain types of plants can live in certain environments. You're going to go on after this part of the lecture, and you're going to look at Google Street View for a variety of places that have different types of precipitation. They're all on the west coast of North America, but they have dramatically different climates as you go from south to north. And so what controls climate? And by control, I mean what contributes to the climate? Why do we have certain types of climate in certain places? And there are several things that control climate. The first one is latitude, which we've talked about a lot. How far you are away from the equator or how close you are to the poles. The next one is elevation. Generally speaking, the higher up you go, the cooler it is. Continentality, the distance from the coast. Pressure patterns, we've talked about high and low pressure. Areas of low pressure get more precipitation than areas of high pressure. Wind patterns, if you have trade winds that are blowing warm, moist air from the ocean, you're going to have different precipitation. Topography, so in order to have orographic lifting, which is when air lifts up next to a mountain and you get rain, right? That is a specific topography that comes with that, as opposed to if you have a large flat landscape like we do in Tornado Alley, where we can get tornadoes. All of this is review. We talked about all of these previously, all of these climate controls. We're going to look at a lot of these climographs, which I've showed you, I think, once before. But basically, there's kind of these like handy dandy little thing that lets us see what the climate is like a place. So this one is for St. Louis, Missouri. You can see in St. Louis, Missouri, here is the temperature right here. And you can see that it is coldest January, December, right? It's in the northern hemisphere, so it's got its winter then. Warmest in June, July, and August. Has pretty, a little bit more precipitation in the spring, but a decent amount of precipitation all year long. And this is a little dot showing you where it is. Some of them have a little dot with the map showing you where it is. Some of them don't. But these climographs are kind of a really useful snapshot of what the weather looks like in a place. And so if you look at this climograph, which is for some place different, most of the rain occurring in the winter. June, July, and August, it's very, very dry. Temperature gets warmer in the summer, but you don't have a ton of temperature variation. It's between the low 50s. This is average temperature, mid to high 70s. And so you could guess that this is for San Diego. We kind of have this pretty constant thing, but we only really get rain in our winter. So the first climate I'm going to talk about is tropical humid climates. They only occur in the tropics, between the Tropic of Cancer and the Tropic of Capricorn, those two latitudes that we talked about before that are very important. They are warm and wet. They have varying precipitation patterns depending on how close they are to the ocean. But all of these tropical humid climates occur in the tropics. And so the first one we're going to talk about is tropical wet. So these are all tropical humid climates. So here's a picture of one in Malaysia. So again, lots and lots of vegetation. You can see here, this is in Peru, right? We're pretty warm all the time. We're always about, 80 degrees or 90 degrees. Lots of precipitation year round. We do have some precipitation pattern here, but again, always, always wet, always, always warm. And when you look at daily rainfall in these places, you typically it's kind of dry overnight. As everything heats up during the day, you wind up getting this massive late afternoon rainstorm, and then it will repeat itself. So thunderstorms or heavy rains in the afternoon are pretty common. So again, close to the equator, always warm, always wet. They get that rain from that ITCZ and convection. They get trade winds from the coast blowing even more moisture there, and you get this tropical rainforest vegetation. Tropical savanna, which also occurs in the tropics, is a little bit different. So it's a little bit closer to the tropics. It's north or south of these tropical wet climates. The ITCZ is ahead over in the summer, but not during their winter. So in the summer it gets very, very wet, but when the ITCZ is far away in the winter, it gets very, very dry, and you wind up getting these savanna-like grasslands that will turn kind of brown in the summer. And so remember, the summer in South Africa is happening in December, January. This is they're in the southern hemisphere. But then in spring, you're going to get a ton of rain. So there is quite a bit of vegetation, but it fluctuates a lot. So you can see here Acapulco, Mexico, and Normanton, Australia. We have reverse precipitation patterns because we're on opposite sides of the equator. This is in the southern hemisphere. This is in the northern. But again, those temperatures are always pretty warm. And again, it's from that shifting ITCZ that in December, January, it's in the northern hemisphere, and then in June, July, and August. I'm sorry, I said that backwards. In June, July, and August, it's in the northern hemisphere, and then when we're having our winter, it's in the southern hemisphere. So you can see here this green band just north of the ITC. These are the tropical savannas in Africa, and they will retreat. They'll get green and then brown and then green and then brown. They'll go back and forth depending on where that ITCZ is, that band of clouds. And so You could see right there, there's a nice animation of it where you have the savanna gets green, then it goes back, green, back, green, back. And that's very typical. Happens also in Brazil, these tropical savannas. The next tropical climate I'm going to talk about is tropical monsoons. We've talked about monsoons before as well. You get winds from the ocean in the summer. It gets very, 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 very wet. Winds from the inland in the winter, and it gets very, very, very dry. So it's more extreme precipitation change than you do get in a savanna climate. This occurs in places with warm oceans to the north or to the south. So here's a climate graph for Myanmar. Again, super, super wet here, almost off the top of the charts. Really, really dry. Same thing that's happening in Liberia here. Oops. And here you can see in India flooding happening from a monsoon. We watched a video about, in the previous module, about how important the monsoons are in India. Next, we're going to talk about the dry climate groups. Places are dry because of prevailing high pressure. Remember, low pressure, we tend to get rain. High pressure, we don't get a lot of rain. Offshore winds, when the wind blows from the continent, it's not picking up as much moisture. And this rain shadow effect, I showed you a picture of rain shadows 2 chapters ago. So kind of a consequence of being on the wrong side of being on the leeward side of the mountain as opposed to the windward side of the mountain. And also extreme distance from the coast, but not always. They don't always have to be extremely distant from the coast. So the first one in that group is the subtropical deserts. So Arizona exists in a subtropical desert. So you're away from the ITCZ. The ITCZ is not really affecting your weather anymore. You're always in this area of high pressure. You're often in a rain shadow, often on the western edges of continents, near cold currents. So you have that trade winds coming from the east, not picking up any moisture because you're pretty far from the coast. And you can get some rain in the summer from convection, right? Arizona does in the desert can get rainstorms in the middle of the summer. They're usually brief. It just happens because it gets so hot that warm air rises and eventually some condensation occurs. But you can see over the course of the year, not a lot of rain, definitely drier in the summer. And so you can see the opposite temperature things because we're on opposite sides of the equator here. Right, Yuma, Arizona is having their summer then. You can get pretty big temperature shifts in the desert. Like it's always pretty warm, but it can get pretty darn cold at night in the desert in the winter. And again, these are occurring where these bands of these subtropical highs are happening. So you're not getting a bunch of rain. The Atacama, that should be on one line. The Atacama, it's not Atacama, a desert. The Atacama Desert in South America is one of the driest places on the planet. Very little vegetation is there, and some of the vegetation that is there, there's no rain falling there in a lot of the places, and so it's actually just grabbing what little moisture there is from the air. But you have kind of this perfect thing where you have this cold current that's happening here. The trade winds are coming across a big continent. You're getting a rain shadow effect on the other side of the Andes Mountains. It's, if you look at some pictures of the Atacama Desert, it is an incredibly, incredibly dry place. So we get these coastal deserts near these cold currents. So again, Baja is another one, right? The cold California current here, off the coast of southern Africa. The next dry climate type we're going to talk about is the mid-latitude deserts and steppes. So I'll explain what a steppe is. But mid-latitude continental interiors and western edges of continents is where you see these. They are very, very far from a source of moisture. You get some convergence at the polar low, but there's just very little moisture in the air for any rain to happen. Steppes are basically just a little bit wetter than deserts. They get a little bit more rain. And so you can see here is Patagonia, Argentina, not just an outdoor brand, but also a place that's very, very beautiful that I've been to. But you do get more vegetation. You kind of get these grasses that happen. Denver is an example of a steppe. they get 14.3 inches of precipitation a year, which is not a ton, but it is more than a typical desert. Oops, excuse me. And so we can see here's one in Russia, right? We're definitely going to get very, very hot in the summer, colder in the winter, but generally speaking, not a lot of precipitation. Here is, so this is a desert. This is a steppe over here. Very, very similar pattern, but you're going to get some more precipitation. Next are the mid-latitude climates, and again, we're just traveling farther away from the equator. These tend to be mild, not too cold, not too hot, just outside of the subtropical zones. Some are very wet and some are very dry. The first one I'm going to talk about is the Mediterranean climate, which is what we live in. And so if you look at a map, where are they all located? On west coasts of places between 30 and 45 degrees latitude. In winter, you get winds from the ocean and it gets wet. In the summer, you get winds from inland and it's pretty dry. You get cold currents near subtropical highs, so overall it is pretty dry. It's not a ton of precipitation. Here is our coastal sage scrub in Imperial Beach, which is a very kind of typical Mediterranean landscape. Very moderate temperatures. Here's a climograph for LA and one for Cape Town, South Africa. Cape Town, South Africa, this is their winter when they're getting their rain. So do get some rain, but generally really mild temperatures, right? San Diego has some of the best weather in the United States. And so here are some other Mediterranean zones. This is Valparaiso, Chile, Cape Town, South Africa, Trogir, Croatia. And you can see they all have like very similar vegetation types. The next is the marine west coast, which these are the west coast between 35 and 60 degrees. North and south of Mediterranean climates, depending on if you're in the northern or southern hemisphere. Very, very wet winter, drier summer, but you're still getting a decent amount of rain, right? Pretty darn green there. Sitka, Alaska is this type of climate. So drier summer in Sitka, but still a lot of precipitation year round. They exist along a polar front. They get lots of cyclonic storms that take place there. But, you know, very, very green in the summer and in the spring, and not as cold as inland ones. Humid subtropical, which occur between the latitudes of 20 and 35 degrees. I want you to also remind you, you do not need to know the latitudes of this. It's more for our discussion. These happen on east coasts, right? So we were just talking about west coasts. They have very, very rainy summers, warm summers, mild, damp winters. So Hong Kong is an example. They're the opposite of Mediterranean, basically. The wind blows from the ocean in the summer and from the land in the winter. So they get their rain in the summer. Next, we're going to talk about the severe mid-latitude climates and tundra. So we're getting cold. Only happen in the northern hemisphere. They only happen in the northern hemisphere is because there's just no land in the southern hemisphere really at this latitude, which is why we don't have them. They would exist if we had big land there, but we don't. So no land in the southern hemisphere at the latitude. So these severe mid-latitude climates and tundra only happen in the northern hemisphere. They get severe cold winters because of the latitude and also because of continentality, right? You're going to be very, very far from the ocean in much of this, and so you're going to lose a lot of that kind of tempering effect that the ocean has. So first is the humid continental ones. So here's a picture of Madison, Wisconsin, and all of their snow, which I could live without. So these are mid-latitude East Coast and inland, and also much of continental Europe. They're rainy, they're snowy. The jet stream kind of brings in big storms. So New York City, which is in this humid continental climate, gets around 50 inches of rain a year, so a lot more rain than we were looking at a minute ago. Seattle gets actually less rain than New York does. It just rains all the time. They have a really large temperature range. Here's a temperature range for Chicago, Illinois, and for Shenyang, China. And so you can just imagine, like, if you've been to Chicago or ever lived in Chicago, really, really cold in the winter, but really, really hot in the summer. The next is subarctic, and now we are really getting out of my comfort zone of temperatures. High latitudes, usually inland. This is Yakutsk, and this is Upernivik, Greenland. They are cold, very cold, but they still have huge temperature ranges. So they're never going to get much warmer than the 50s, but they'll go down to minus 20 Fahrenheit. So that's still a huge temperature range. Relatively dry year round. Not lots of rain happening here. They will get some thunderstorms in the summer, but generally speaking, pretty darn dry. I believe this is the last one, which would make sense, is the ice caps, right? Greenland and Antarctica. The mean temperature is always below freezing. It's very, very, very dry. There is no vegetation. Oops, sorry. Actually, there's one more thing we're going to talk about, right? So even though you're getting a big temperature range here, it only goes up to just over 20 degrees Fahrenheit, goes all the way down to about minus 40. In Greenland, too, you're never really getting up to above 20 degrees. Greenland is not green at all. Iceland can be very green. They're named backwards. But that's a story for a different class. The last thing I want to talk about is highlands. Highland climates are just colder and wetter than the nearby climate. So Julian is a Mediterranean highland climate. They're not their own climates. It's just that they have a lot of aspects of the adjacent climate, but because they're at a higher altitude, they're a little bit different due to this adiabatic cooling, right? This orographic lifting and this adiabatic cooling. There's no exact minimum elevation for them. They're just kind of a subset of the climate that they're adjacent to. And so here you can see, map is really light in color, but hopefully you can see it. You don't have to know this, but highland climates along the western United States, parts of Africa, parts of interior Asia, the Alps, you're getting right over here. And so this is the last slide for this part of the lecture, and then we're going to move on to, in the second part of the lecture, we're going to talk about global climate change. But just a cool slide showing you the really kind of variation in climate and weather that we get on this planet. You know, temperatures up to 136 degrees, no rainfall, 460 inches of rainfall. And so you'll hear from me again in the second half of Chapter 8.